Alright, now what if we've got to translate one? Let's say we've got something in the form of y equals log base b of x minus h plus k. Well, the minus h is going to be your horizontal translation. The plus k is your vertical translation. And remember, it's the bad twin here, so it's going to do the opposite of what we would think. What we're going to do with this, we're going to just translate the parent of y equals log base b of x. Okay? So here's the one we're going to graph. We've got y equals log base 2 of x plus 3 plus 1. Well, we're going to graph the parent, which is log base 2 of x. Okay? That's the parent. How do we graph it? Well, we're going to get some points by taking the inverse. Okay? We're going to graph it by getting some points by finding the inverse. So this is 2 to the negative second power, which is 1/4. 2 to the negative first, which is 1/2. 2 to the 0, which is 1. 2 to the first, which is 2. And 2 squared, which is 4. Got nice numbers. We can graph these. So now we switch them. I've already switched the x's for the y's here. Now all I've got to do is fill in my x's. Okay. Once you do that, now we're going to graph. We're going to graph this one, and I actually already have it graphed on my next slide. That's the parent, okay, where I've plotted those 5 points. Now what we're going to do is we are going to translate left 3 units and up 1. So each one of these points, I'm going to move it left 3 and up 1. And then I'll be done. So here's this one. I'm going to go 1, 2, 3, and up 1. That one's going to come back to 1, 2, 3, and up 1. Here is going to be 1, 2, 3, and up 1. Okay. 1, 2, 3, up 1. 1, 2, 3, and up 1. And here is the translated version. Okay. Now, eventually you'll get quick enough to where you may not have to graph this one. Okay, the more you practice this, the better off you'll be. Let's see, the equation was originally y equals log base 2 of x plus 3 plus 1. Okay, the domain in this case. Okay, your domain is going to be x is greater than negative 3, and your range will be all real numbers. Okay. Exponentials and logarithmic functions are inverses of each other, so the inverse would have a switched domain and range. Alright, logarithmic equations. Logarithms, like exponentials, sometimes you can, as long as your log and the base is the same, you can just set those arguments equal to each other. So I've got the natural log of this equals the natural log of that. So this better equal that. So that's what we do. 7x minus 4 equals 2x plus 11. And we solve. Subtract the 2x, add the 4. 5x equals 15, x equals 3. And of course you should check your answers. This one will let it kind of go, but it does work. I did check my answer before the video. Okay. What if they're not taking a log of both sides? What if this, like we've got here, log base 2 of x minus 6 equals 5? In this case, we need to get the x out of this logarithm, and the only way to do that is to switch to exponential form. So that means 2 to the 5th power equals that. Okay? So that's what we're going to do. 2 to the 5th power equals x minus 6. So that's 32 equals x minus 6. Add 6 to both sides, x equals 38. And you can check your answers quickly if we plug that in. 38 minus 6 is 32. 2 to the 5th does indeed equal 32. What if we have an expanded logarithm? Okay, here's one that's got an x here and an x here, and it equals 2. What do we do here? Well, before you can do anything with switching to exponential form, you have to have it written as one log, a single log. So we have to condense it. So, let's see, this is a log plus a log. Well, that tells me, that plus sign tells me it's the product property. So what that means is that this is going to be the log of 5x times x minus 1 equals 2. Now we have it written as a single log, and I'm going to do things in 2 steps because I'm limited on space here. I'm going to distribute and switch it to exponential form at the same time. So log, if the log doesn't have a little number written here, it's a common log, which means it is base 10. So that means 10 to the second power equals 5x squared minus 5x. Okay. Oh, I have an x squared. That's a quadratic. That tells me I better set everything equal to 0 to solve. So let's square that, move it over. So we've got 100 equals 5x squared minus 5x. Move it over. 0 equals 5x squared minus 5x minus 100. Now, I don't want to factor that because I see 5, 5, and 100. I can divide all of this by 5. That's going to give me 0 equals x squared minus x minus 20. That looks much nicer to factor to me. 0 equals x minus 5, x plus 4. Okay. Remember, factors of 20, that'll subtract to 1, negative 5, and positive 4. So x equals 5 and x equals negative 4. This is where it's extremely important to check your answers. So when we check, let's check the 5 first, just because I did that one first. So the log of 5 times 5, that's 25, plus the log of 4. Does that indeed equal 2? Use your calculator. Common logs, use your calculator. Check, it does, so 5 is definitely an answer. Now let's see if negative 4. Negative 4 times 5 is negative 20, plus the log of negative 4 minus 1 is negative 5. Does that equal 2? Well, think about it. If I'm taking the log of something, it's got to give me an exponent. Is there an exponent of 10? Is there a power of 10 that'll give me a negative answer? Okay. Is there a power of 10 that'll give me a negative answer? Can I take 10 to any power and get a negative answer? Oh, some of you would say 10 to the negative 2 is negative 100. But I think you're out of your mind. So, no. The fact is, this is not real, so it is not a solution. If you put that into your calculator, it'll tell you an error. Okay? So, this is what's called an extraneous solution. We get those sometimes with logarithms. Next one. Here's another one where we've got to condense it. This time it's base 4. Pay attention to that. Okay, so log base 4 of x times x plus 12 equals 3. Okay. Convert to exponential form and distribute 4 to the third power equals x squared plus 12x. 64 equals x squared plus 12x. It's an x squared, which tells me I have to set it equal to 0. So x squared plus 12x minus 64 equals 0. Factor, what are the factors of 64 that'll subtract to 12? Well, 4 and 16. Since 16 is greater, 16 gets the plus, the 4 gets the minus. This is x, this is x. So x equals negative 16 and x equals 4. Now, check your answers. If we plug in negative 16, okay? If we plug in negative 16, we're going to get the log of 4 equals negative 4. That's another one where we can never get it. So guess what? Negative 16 is not a solution. Does that mean I don't need to check 4? No, you still need to check 4. So let's try it. The log base 4 of 4 plus 12, does that equal, or plus the log base 4 of 4, does that equal 3? Well, log base 4 of 16 plus the log base 4 of 4. Okay, well 16, 4 to the second power is 16, so that's 2. 4 to the first power is 4, so that's 1. Check, it does work.